Okay, so in this video we are going to be talking about the attributes of quadratic functions. Okay, so the first thing I'm going to do is take my equation and put it into the calculator so I can get all my points. So negative x squared plus 6x minus 5. So let me go to the table, and I want to start right in here, but what I want to make sure that I include is my vertex. And I have it right here. And so I can always identify my vertex because it's the one with the y value that's not repeating. So you can see how I have these repeating y values around me. So let's see, if I do 1, 2, 3, 4, 5. So when x is 1, y is 0. When x is 2, y is 3. When x is 3, y is 4. And then when x is 4, y is 3, and when x is 5, y is 0. So again, my vertex is 3, 4. And then for my axis of symmetry, I always pull my x value from my vertex, because remember, this is the one that is cutting my parabola in half. So this would be x equals 3. Okay, and now I need to find my x-intercepts, and that's where my y value is always going to be 0. So looking at my table, I can already find them, that it's 1, 0, and 5, 0. Okay, and then it's asking for my a value. That's always the value that's in front of the x squared. So here a equals negative 1. And now using my vertex and my a value, I'm going to write my vertex form. So remember, this is a times x minus h squared plus k, where your vertex is your h comma k. Okay, so that means I would have negative 1 times x and then minus 3, because remember, this is going to be h and this is going to be k. Okay, and then squared plus my k value, which is 4. Okay, and then from my vertex form, it wants me to describe the transformation that's taking place whenever I compare it to my parent function. So if you'll recall, my parent function is x squared, and then I'm going to put this one in, negative 1 times x minus 3 squared plus 4. So let's go to the graph. So the first one is my quadratic parent function, and the second one is my new equation here that I typed in from the vertex form. And I can see, since it's flipped upside down, that means we have a reflection. And then it is shifted it has shifted sorry, to the right, and then it's shifted up. Okay, and this is what tells me also, without even putting it in the calculator, that it shifted to the right because it's a negative, and then that it shifted up because this is a positive 4. Okay, so now going on to our next one. So again, I'm going to go into y equals. I'm going to put in my function here, 2x squared plus 12x plus 19. I'm going to go to my table, and I'm looking for my vertex, and there it is right here, negative 3, 1. So I'll go ahead and write that, negative 3, 1. Okay, so that means I needed to negative 4, negative 5, 2, and negative 1. So I'd have 9, 3, 1, 3, 9. Okay, again, my axis of symmetry is going to be my x value of my vertex, so that's x equals negative 3. Okay, and from here I couldn't find, from my table, I couldn't find the x-intercepts. So let's even see if it crosses the x-axis here, and you can see that it does not, so I would not have any x-intercept. So this is going to be none. Okay, so next it wants the a value. So a value, remember it's always the value in front of the x squared, so it's going to be 2. So now I'm going to write my vertex form, again using my a value here and my vertex. So that would be 2 times x minus, but since this time I'm inputting a negative, that's going to become a positive. So plus 3 squared, and then plus 1. Okay, and then instead of looking at the graph, we'll just go ahead and describe it from our vertex form here. So since a is greater than 1, that tells me I have a vertical shift, I'm sorry, not shift, stretch, because it's getting narrower. And then, since this is plus 3, this means it's shifted to the left. I could even say 3 units. And then this plus 1 tells me shifted up 1 unit. Okay. So let's move on to our next one here. So again, going back into y equals, we do negative x squared plus 2x plus 3. So let's go to our table and find our vertex. And there it is, 1, 4. So my vertex is 1, 4. That means I need to find negative 1, 0, 2, 3. So when x is negative 1, y is 0. When x is 0, y is 3. We already have that one. And 2, 3, and 3, 0. All right. So my axis of symmetry, again, it's going to be my x value of my vertex. So x equals 1. And then I want to find my x-intercepts. So that's whenever my y value is 0. So I'm able to find them from my table here. So it's going to be negative 1, 0, and 3, 0. Okay, and then I need my a value. So again, that's always the value in front of my x squared, so it's negative 1. So now I'm ready to write my vertex form using my a value and my vertex. So that would be negative 1 times x minus 1 squared plus 4. And then just using my vertex form, I'm going to write out the transformations. So from the negative 1, I can see it is a reflection. And then this minus 1 tells me it's shifted right 1 unit. And this plus 4 tells me it's shifted up 4 units. Okay, so let's go to the back side here. There you go. Thank you. You're very welcome. Okay. So now we have, I'm going to do my alpha y equals inner 1 over 2 x squared plus 2x plus 4. Then going to my table and I'm looking for my vertex. Let's see. Okay, here it is right here. So it is negative 2, 2. So negative 2, 2. So that means I'm looking for also negative 3, negative 4, negative 1, and 0. So then that would be 4, 5 over 2, 5 over 2, and 4. All right. So this is for, I believe, sorry, I've already forgotten. Axis of symmetry. So axis of symmetry, so I don't forget. Axis of symmetry, x-intercepts, my a value, vertex form, and then transformations. Okay, So again, my axis of symmetry is going to be my x value of my vertex. So that's x equals -2. My x-intercepts, let's see if it crosses my x-axis. So when I graph it, I see that it does not. So that would be none. My a value, remember that's always going to be the value in front of the x squared. So that's a equals 1/2. So now I can write my vertex form using my a value and my vertex that I have here. So that's going to be 1/2 times x minus, and since my x value here, or my h value is negative, this is going to become a +2 squared and then +2. And now my transformations, this time my a value is between 0 and 1. So that means I have a vertical compression. Okay, and then this +2 tells me it's shifted left 2 units. And then this +2 here tells me it shifted up 2 units. So shifted up 2 units. Okay, so now we have this function. So going back into y equals, we have 3x squared plus 6x. Go to my table to find my vertex, and I see it right away, -1, -3. So this is going to be -1, -3. So that means I'm looking for -2, -3, 0, 1. So I would have 9, 0, 0, 9. Okay, so now using my vertex here, I can find my axis of symmetry. It's going to be x equals -1. And now I need to find my x-intercept. So again, that's always going to be where y is 0, and I have it here on my table. So it is -2, 0, and 0, 0. Now my a value, again, always what's in front of x squared, so that's 3. And now we can write our vertex form. So that's 3 times x minus, but since I have a negative here, I'm going to make it +1 squared. And then instead of +3, it's going to be -3 since it's a -3. All right. So using my vertex form here, I'm going to describe the transformation. Since a is greater than 1, since a is greater than 1, that means I have a vertical stretch. And then inside the parentheses, this +1 tells me I have shifted left 1 unit. And this -3 tells me I shifted down 3 units. Okay. Our next one here, so going back into y equals, we have x squared minus 6x, thank you, plus 5. So going back to the table, looking for my vertex. And here it is. It is 3, -4. No, you got it. So 3, -4, right? Yeah, 3, -4. So 3, -4 is 32, 1, 4, 5. So it is 0, -3, -3, 0. Okay. So again, using the x value of my vertex, I can find the axis of symmetry. It is x equals 3. Now I need to find my y-intercept, so I can look at my table. It's always where, not my y, I'm sorry, my x-intercepts. And using my table, I can always find it by finding the ones that have a y value of 0. So 1, 0, 5, 0, those are my x-intercepts. Now my a value, again, always what's in front of the x squared, so this is 1. So now writing my vertex form, I have 1 times x minus my h, which is 3 squared. And then instead of putting a plus, I'm going to say minus because my k value is negative here. And now we can describe our transformations. There's not anything going on since my a value is just 1, so there's no vertical stretch or compression. But this minus 3 inside of the parentheses tells me I have shifted right 3 units. And this minus 4 tells me I shifted down 4 units. Okay, last one. So y equals, I have negative, so that's negative 1 over 2, and that's x squared plus 6x minus 18. Going to my table, looking for my vertex. And there it is. So it's at 6, 0. So 6 zeros, that means I'm looking for 7, 8, and 5, 4. I just went in the opposite direction. I don't know why. So it's 4, 5, 6, 7, 8. Okay, so at 4 we have negative 2, and then 5, negative 1 over 2. 0, and then negative 1 over 2, and negative 2. Alright, so now for my axis of symmetry, we have x equals 3. And then for my x-intercept, it's actually going to be my vertex here. And I know that it's only going to be my vertex because that's the only one that's going to have a y value of 0 here. My a value, again, looking at what's in front of the x squared, so that's negative 1 over 2. And now for my vertex form, I have negative 1 over 2 times x minus 6 squared. And then I don't need to put anything over here because it's 0 and that wouldn't change anything. So now to describe the transformations, I know that I have a reflection because this is negative, so we can say reflected. It's supposed to be a C. And then we have a vertical compression because my a value is between 0 and 1. And then from the inside of my parentheses, this minus 6 tells me it's shifted right 6 units. And that completes our paper on attributes of quadratic functions.